Today we're going to evaluate this integral you see here that has this gunk in the exponent 3 minus 4x, and so we have to deal with that. When we're looking at an equation like that, the thing that should come up to your mind is a u-substitution. And basically what we want to do is we want to take all that gunky stuff that we don't know how to deal with and just turn it into a u. So in this case, u is equal to 3 minus 4x, and we take our derivative of u is going to be a negative 4 dx. So take your derivative of both sides, and in this case, notice we don't have a negative 4 popping up in our integral. So what we're going to do is we are going to move that negative 4 over to the left-hand side. So in other words, negative 1/4 du replaces dx. So we have the two parts that we're going to replace. We're going to replace 3 minus 4x, and we're going to replace that with a u, so e to the u. And then the second thing we're going to replace is, in place of a dx, right, we're going to put the stuff on the other side of the equation, the negative 1/4 and the du. Now, because that negative 1/4 is just a number, let's pull it all the way outside of our integral. Don't forget we can do that. So we end up with negative 1/4 e to the u du. And this, of course, is the nicest integral to integrate whatsoever because our constant comes along for a ride, and the antiderivative of e to the u is simply e to the u. And since we have an indefinite integral, which means we have no bounds, we are going to add on a plus c, our constant that comes along for the ride. Last thing that we want to do, and this is the step we don't want to forget, we want to go back to our x's. With an indefinite integral, if you start with x's, you should always end with x's. So we got to do that substitution back in. And our solution is negative 1/4 e to the 3 minus 4x plus c. Thank you for listening.